Hello, in this video I wanted to show you how you can integrate Cisco Cyber Vision with Cisco Identity Services Engine using a pxGrid interface. This interface will pass attribute information that is discovered by Cisco Cyber Vision from an operational domain assets and pass them into the policy engine of the Identity Services Engine, which can then profile and provide Trustsec segmentation capabilities to industrial switches that are connected to ISE. So let's have a quick look at the agenda for this demonstration. We're going to investigate pxGrid interface and how it's configured on both platforms. Then we'll have a quick look at how I've built a profile and authorization policy to trigger on changes that can be passed across this interface from Cisco Cyber Vision. And then we'll have a look at a demo where I actually make some changes, and we'll look at the implication of that and how it's visualized both on Cisco ISE and how it's manifests itself from an endpoint perspective. And finally, we can look at the CLI changes on the IE4000 and how this Trustsec capability manifests itself at the switch level. So quick examination of the lab setup for this demonstration. You can see from a platform perspective, I've got the Cisco Cyber Vision 3.2 connected over a pxGrid interface to Identity Services 3.0. The Cyber Vision platform is collecting span data from an IC3000 sensor, which is connected into a port on the IE4000. The IE4000 is radius connected for the Trustsec segmentation component into Identity Services Engine. And then I have three subtended devices that are acting as though they are in a manufacturing cell. One is a Schneider PLC. The second is a Unity Pro programming workstation, and the third is a Modbus client. This is collecting data from the Schneider M340 PLC. So the starting position is that I've defined some groupings within Cyber Vision. These are virtual groupings that allow devices to be compartmentalized, and they're compartmentalized such that the information that goes across the pxGrid interface will indicate to Identity Services Engine exactly where those devices reside, such that policy can be built based upon some profiling. So the default state is all endpoints are in cell 1, and you can see I have this hierarchy where I've got a main plant grouping and I've got a cell 1 grouping inside that. So in the first part of the demo, we'll have a quick look at the profiling around that and how it looks within ISE. So let's move forward and take a look at how we're going to do some segmentation. So I have a second grouping defined called cell 2, which is in this main plant. And what we'll do is we'll take the Modbus client endpoint and we'll move that from cell 1 into cell 2. That will correspond to a change in a dynamic attribute that Cyber Vision will send across once we make that grouping change, and it'll send that attribute across to ISE, which in turn will affect the authorization that is enabled against that endpoint. That will then be assigned a different SGT18, that will be indicated down to the IE4000, and we'll see that there's actually a matrix, a Trustsec matrix set that doesn't allow any connections between cell 1 and cell 2. So first, let's take a look at Cyber Vision in a small lab network. Let's look at the pxGrid interface and show how it's possible to configure the connection between Cyber Vision and another device like Identity Services Engine. And then we'll take a look at that side and see what the configuration looks like. We'll then take a look at the way the attributes are passed across from these devices that discovered. The pxGrid interface is configured under administration. So if we click this, we'll drill down and we'll see that there's actually a menu item for pxGrid. And very simply, you add in a certificate from the pxGrid side. You generate a certificate locally here, and that download will give you locally to upload into the Identity Service Engine or another platform. You need to have a node name that appears on ISE as the service derivation. And then you can see you need the host name, and you absolutely do need to have name resolution working between these components. And then you've got the address of the ISE server. So something that's unique about this integration is the fact that we're able to translate asset information from an operational domain, that is values that would typically not be seen or understood by an IT level management platform. We can pass those attributes across a link, and effectively Identity Service Engine will be able to profile upon those attributes. We'll be able to use that profile in policy to generate policy decisions that can segment in a very dynamic way. So let's take a look at what's actually running in this small lab, and let's drill into the data that's actually being provided. So if we do an explore on the data that's there, you can see I've already done some pre-filtering by defining the preset called cell 1. And if it drills into that, you'll see there's a much reduced number of devices. So if we look at the component list for this, you'll see there's actually really only 3 devices in the particular grouping that are enabled for Modbus. One is a Schneider M340 PLC. The second is a PC running Unity Pro for programming, which is the Cisco SCH device. And then I've got a client that's actually pulling data from the Modicon controller. And those devices I've arranged into kind of groupings. So let's have a look at the way I've arranged them into groupings by looking at a map view of the same data. I've created some groupings to subtend these devices into. I have main plant grouping, and then under that I've got a cell 1 grouping, and you can do this nested grouping in version 3.2 of Cyber Vision. So each of these devices, when they're discovered, contains a number of attributes. So if I click on any of these devices or links, I'm going to get more data about the device. And as you can see, this is a Windows 7 machine. If I click on the technical data sheet, you will see more information about what the NetBIOS name is. And we have the ability to pass quite a lot of this attributes information across to ISE to actually do the profiling and then ultimately build policy. So let's move across and take a look at Identity Service Engine. This is actually running version 3, the latest version of ISE has released in 2020. And you can see that I've actually got some endpoints discovered. These endpoints are the same endpoints that we're actually discovering with Cyber Vision. In this case, these devices have been authenticated into ISE already from a Cisco IE4000 using MAB. So they're already discovered. And what I'm going to do is overlay information that's now discovered on top of that based upon attribute values that are provided by Cyber Vision. Simply when you're defining the pxGrid interface, and let me just drill quickly into that. If I go to administration, pxGrid services, you have client management, and you will see within the clients, CV32, if you remember, is the name that I'd configured in the pxGrid interface on Cyber Vision to enable the interface between the two devices by generating a certificate, which I then populated back in Cyber Vision, as well as importing a client certificate from that side into the trusted certificates that existed already on Identity Services Engine in the certificate store. So if I just jump to certificates, trusted certificates, you'll see this Cyber Vision C2 is the certificates I imported from an export from the Cyber Vision platform. So if we look at the PLC first, which I know is this 10.00.76 address, and we kind of drill into the attributes that ISE knows about it. Let me just slide down to the bottom of this list. At the bottom of the list, you'll see a number of these values that start asset device type, controller. These are all attributes that are passed across that pxGrid interface. So you can see, first of all, it's a controller. You can see the protocols it's using, specifically Modbus and UMass. And you can actually see the software revision of this particular PLC controller. So all this information can be used in ISE to profile the endpoint and ultimately to build policy decisions. In addition to these attributes at the bottom of the list, there are some extended attributes. These are values that are being added to the data dictionary specifically to support Cyber Vision. And at the top, you can see values that have come across the interface, like the ones at the bottom, but you can see some interesting extra information here. First of all, you can see an asset grouping, cell 1, and you can actually see a group path, which is basically a tree of groupings. We can use these values, and we're going to go back and look at this in a sec, to do dynamic changes of policy over on ISE based upon changes that we make in Cyber Vision to where devices reside, which particular groupings they're in. So let's take a look how we built a very simple policy based upon the attributes that Cyber Vision is providing. So here, if we go back in ISE and we take a look at the active endpoints, you'll now see that there's a profile associated with this. So how did that process work so that we can then use that value there as an active enabler to allow connectivity or not within a Trustsec enabled switch? So if we, on the dashboard, if we go and take a look at the profiles, you see I have a couple of profiles that I've defined at the top. And the important value here is to look at the rules. A simple rule set in this profile that would make the profile active if it was true. And effectively what you can see I have is there's a custom attribute called asset group, and if it equals cell 1, this is the profiler policy name. Now you'll recall that this actual value comes across as a dynamic attribute in the custom attributes at the top of you see it at the top of the endpoint attribute list. So if we take that value and we then go and look at the policy that's associated with this in the policy set, if I move to the authorization policy section in the policy, you'll see that if my endpoint profile equals 1-L1, permit access and apply the security group to it. Conversely, if it equals 1-L2, apply a different security group to it. And if we look at how they're actually being used within the matrix for Trustsec within the platform, first of all, I've got a couple of security groups defined. Here you can see Modbus cell 1, Modbus cell 2, and they're the values that are passed down, in this case, an IE4000 switch. And if I actually look at the matrix that's defined for this particular policy, I've built a mini section, and you can see that I'm saying if the traffic is from Modbus cell 1 to cell 1, then permit it. And I have a simple deny statement if it's between 1 and 2, and 2 and 1. So effectively, if I move things into something called cell 2, then I would expect traffic to stop. So if we do an explore on the system, you'll see that I've got a preset defined called cell 1. Within the preset, if I click on it and we look at maybe a map, you'll see that I have a main plant grouping and then a subtended group called cell 1. And all these devices in cell 1, this reflects absolutely what you're seeing in ISE. So if I switch quickly to ISE, the profile is based upon the cell, and if you recall, the endpoint attribute showed those values. So let's move back to Cyber Vision. Now, should I take one of these devices, and in the background I've actually got traffic running. So here we have the actual program PC. You can see attribute values changing as I'm dragging Modbus values from the PLC. I'm also pinging out this device to the Unity PLC, that's the programming workstation. And when we make some policy changes, we should see the data on this screen stop as we're in a kind of a blocked situation. And if I was to take this PC, which is the same one that we're looking at, and I click on it, I've got this option here to manage groups. So I can take this device and I can move it into a completely different group. Now I've already got a grouping called cell 2 defined. As soon as I OK, you'll see the different grouping here called cell 2 that the device is in. But that has made a dynamic change across the interface towards ISE that you will see as a knock-on effect of impacting the policy decision engine. So let's take a look at the live session logs. Are always good to look at in this particular case. And hopefully here we go. You can see that now the profile has changed to 1-L2 for this endpoint, which is the device that moved. We have a different policy, and actually it's now been allocated into a completely different secure group tag. So if we look at the actual endpoint itself, you will find now that actually the Modbus program has stopped, pings have stopped, because we've actually done a dynamic change that's now segmented a device from the other devices. Let us reverse the action. Let us move the device back into cell 1, and that should restore service. We'll do it again, and we'll take a look at what the switch sees from a CLI perspective. So if I move here, I click on this device and I change its group, and I move its group back to cell 1. What that should do is that should restore the connectivity between the devices. And a good place to always look for this kind of thing is in the live sessions log, which will take a few seconds to catch up. Okay, now you can see it's completed its reauth on the endpoint. It's back in that security group, and I would hope that we have now restored service and you can see the pings have started, and I can restart the reads for Modbus. Let's go back and let's take a look at what the switch sees. If we look at Cyber Vision, everything is in the same virtual container of cell 1. So here we have an i4K, and all the endpoints are in the same actual switch, and they've all been MAB authenticated in the first instance. So they're actually these 3 devices on these 3 ports. You can see they're all MAB'd. So what we can do is take a look at some of the Trustsec configuration. So from a dynamic push, I mean, and I guess most people realize that we're using radius from the switch to ICE to pass this information down. So that's how the switch is able to do the segmentation piece. But you can see here that that particular rule set that we saw in policy is being pushed down to this particular switch, and it has those endpoints to protect. So it's very well aware of where it needs to segment and how to segment if changes should happen. So if we look at the SGT map for the switch, you'll see that all the devices are in the same SGT. This corresponds with the SGT values in the ISE engine. So now go back and we'll move again this device into a different grouping. So we'll move it to cell 2. And this is what kicks off that whole process effectively. So let's now go across to the switch and see what impact that had when we made those changes. And as you can see, it's obviously stopped the traffic. So if we look at SGT map all, we'll now see a difference. So you can see that this endpoint, which is the one that we're actually sitting on here, has had a different SGT push to it. And we know the effect of that. We'll also see a change in the way the policies have been applied. And this is all in line with what you kind of expect to see. So ultimately, what I'm trying to show you is how Cyber Vision's integration with things like ICE can really help various levels of segmentation. This is effectively micro-segmentation, but it could be used on a much more macro scale. But it was to give you a kind of a lab example of how that integration works.